Welcome to Casting Class, the engineer's podcast for all things metal casting. Casting Class is brought to you by Batesville Products, the manufacturing experts who've been casting, machining, and polishing custom aluminum components for over 75 years. Your hosts today are Tim Williams and Rachel Weber, here to talk about designing metal castings.
So this has been a hot topic for us in the past, so I wanted to go back and add some things we've heard over the past year or two, questions we've seen from years of reviewing drawings, talking to clients in different industries, different arenas of casting need, and we'll get this kicked off.
Yeah, so just kind of brief of what the benefits of permanent mold is as compared to maybe die casting or sand casting is that one, you'll get extremely low porosity castings, which is good for a lot of different industries. High precision and detail, great surface finish, whether it's you want to as cast surface or even going beyond that to getting a better polish finish, and then really good complex designs.
There's some great benefits across really all the different types of casting processes. Obviously, as Rachel stated there, those are specific to the permanent mold side of things. But, as we go into it, we'll talk mostly about permanent mold, highlight some areas of difference between the sand and the die casting, but again, primarily share our information around our knowledge on permanent mold. Understanding a lot of this is often key too, so if you understand going into the process, there's benefits in creating the design and the direction you want to get it casted prior to going in. I think that the biggest thing around that is the quickest time to market. So if you come in, you understand the design changes and the things that you want to implement in your casting, again, it helps you direct which way it should be casted and gets that product to market quicker there. The other thing would be more efficient ways to manufacture. So you design it correctly. If it's designed for die casting versus a permanent mold or sand casting, there's different benefits to all of it, and it really helps you really understand the direction you need to go and be most efficient and quick to market in those processes there.
Yep, like we always like to say, start with the end in mind.
Absolutely. So the first thing we'll talk about is wall thickness. Rachel?
Yeah, sure. So in general, 180 thousandths is pretty standard for permanent mold. I would say that's your minimum on most cases, and when you're looking at designing for permanent mold, or really almost any casting that is gravity fed, is you want to consider having consistent wall thickness for your casting, and then looking at maybe machining or polishing to get down to your exact wall thickness you want. Because if you have too much variance in your wall thickness, you'll see it either freeze out in certain areas and you'll get non-fill. So it just makes it a little bit harder for it to cast if you require a lot of different wall thicknesses throughout the casting.
Yeah, I think it's important. The biggest thing this is trying to solve is making sure you can get a casting, right? Yeah. So to Rachel's point, if you're casting thick sections, it's going to be, or it's going to create different issues as you try to cast that part. So really our goal in stating the wall thickness here isn't to say, hey, your part's too thin or too thick, we need to get it in this direction. It's, hey, we want to set this up and be able to cast good product.
Yep. And
then we can go either direction. If you need it thicker, we can design it thicker. If you need to machine it down, we can machine it down. If it's not absolutely needed, let's design it out and let's get a casting that fits for both the process and the end goal in mind.
Fillets and radii. You want to talk to this one?
Sure. Yeah, so Rachel had talked about there's some technical sides of the casting, not just the wall thickness, that really help the castability, as we would say, of the product. So having your fillets really designed correctly up front helps you, again, on that castability side, to make sure that you're getting a part out the way you want it to look, the quality standards you're expecting to deliver. You touched earlier on surface finish. But really on the casting process side of things, the sharp corners can cause a number of issues there.
Yeah.
So again, we want to make sure we're casting good product coming out rather than having to scrap parts because it's cracking or there's high stress areas, or you mentioned some cold spots, creating tearing in the casting. So really designing that again up front to make sure that that casting comes out to a good quality standard.
Yep. Especially if you're looking at casting that's starting to get larger in size, but you're still maintaining relatively thinner walls compared to the size of the casting. That's going to cool quicker, and you're going to get more tears if you have tighter radii on it, and sharper corners.
Absolutely. So similar in nature, but not exactly the same. So if you have ribs, you can see some of the same issues. So designing ribs with same types of radius, same types of fillet outcomes. But again, it's the end casting in mind. You want to talk a little bit about this?
Sure. A lot of times ribs and gussets are helpful when you have a more complex design. So if you have an area where, for example, again, you have maybe more variance in wall thickness, you can add these ribs and gussets to help fill in areas where maybe the metal would have, if you didn't have it, would have solidified before reaching it. So it helps metal flow to different complex areas in the casting. If you don't need it, then we'll try to design without it, but it is helpful to have those as you start to get into bigger parts in general, and especially where there's going to be a lot more surface area to cover.
Yeah, and I think if we go back kind of a couple slides where we talk about the wall thickness, it really allows you to have some of that complexity without adding that additional cost of a thicker wall, which means more metal, which means more cost. So very, very important to keep in mind as you're designing your part. Again, do you want a good casting coming out? Does it need to be permanent mold? Does it need to be dyed? Does it need to be sand casting? But keeping ribs, fillets, that type of stuff in mind as you're designing this process here.
Yep. Bosses. So you don't always need these, but when you're designing these, it's good to remember just maintaining uniform wall thickness helps with bosses, as well as including draft and fillets to help these fill out correctly.
Yeah, absolutely, and it's definitely something we see a lot in our process. But if you don't design it right, you run into issues. And then, again, Rachel mentioned earlier, but end goal in mind here is to make sure that we're providing a good design, a good casting up front before even cutting the die. Part of the design phase can be creating your ejector pin marks on bosses, on parts of the product itself where you can machine away later. But designing the ejector pin marks into the process where it's not critical, or it's something that we can work around maybe in secondary operations here.
The bigger the surface area, the more you're going to want to have so you can evenly eject it so there's no torque happening when it's coming out of the mold. So those are a lot of things to consider too, is just how evenly you can eject the part out without causing any distortion.
Yeah, you design it wrong and you could twist the part. You could, if you put a ejector pin mark on a really small surface area too, you could end up shooting it up into the casting, and that's something.
Poke a hole.
Exactly. Better way to say it.
Unintentional core hole.
Yep. So that's something you definitely want to look at. And again, we work very interactive with our clients to make sure that we work that type of stuff out, or really try to pinpoint where we might see some of those issues, and try to design it out before the mold's even cut.
Yep. Maximum size.
Yeah, there was a question about a maximum size of a casting and a minimum size of a casting. You want to add color to that?
So it really depends upon the presses that a foundry has. So for example, our largest press at BPI is a stall press. So if you're talking in terms of footprint, there is a limited size in terms of a footprint of a casting, but you can have a really dense up to 100-pound casting that will fit into a normal hall press as well.
Yep.
So really it's just sending over your design to the foundry you're looking to get quoted to see what is recommended. A lot of times I will say the larger the casting gets, sometimes sand casting tends to be the better fit for if you're starting to get over 100 pounds maybe. You would want to start looking at sand casting just due to the sheer size, but permanent mold can get pretty big.
Yeah, there's a lot of times that volume of the product really shifts it towards the specific casting process. Rachel mentioned the sand casting side of things. It allows you to, have a much bigger casting that you don't have to fit inside of a press. Die casting on the opposite side typically are smaller parts just due to the quantity throughput that is required there. So really trying to force metal in. It's a multi-cavity tool where they're looking for hundreds of thousands of parts typically, where it makes more sense in that direction than like a cavity feed or a gravity fed process or a sand casting process.
Yeah.
But as far as like a dimensional tolerance of size of part, from a weight perspective, we cast parts that are under a pound up to, we're looking at some that are 115 pounds. Rachel mentioned the press, not just the size, but also the ability for the press to handle what amount of weight, because you're not just doing the 115 pound part, you're doing the gates and risers that go with it, you're doing the mold that goes with it, and for the press to really be able to handle that. From a spatial capacity, again, for us, the size of the press impacts that. The size of the machine impacts being able to machine it. We live really in like the 36 by 42 space range, but we get creative too.
Yeah.
So there's a question as well around the types of metals. So 6061 is really the extruded or bar stock comparative to like A356 or A380, which are both casted metals of the aluminum nature. And A380 you see a lot in die casting, 356 you see in permanent mold, sand casting.
I would say typically you'll see 300 series for casting mostly.
Absolutely, yep.
So windows and holes tend to be a little more difficult in the casting process, but a lot of times they're needed for the end design. So great ways you can add holes in there and make it castable is either doing bridges or even adding gates and risers to that area, where you use a secondary saw operation to remove it, or even using machining to remove that extra area. But always wanted to make sure you have some type of path so that you can help the metal continue to flow throughout the casting and not get stopped where that window or hole is.
Sure. Yeah, and I think this is pretty common. We see a lot in our process. And to Rachel's point, it being permanent mold's a really good near net shaped casting. It comes out typically with minimum needed secondary operations, and this being one of them. So if you need a cord, you need a window, or you need a cord hole, design it in the mold where we can do some minimum cleanup afterwards if needed. Typically sharp areas, or if it needs a tighter tolerance than the casting itself. But yeah, I mean, great feature, great addition to the permanent mold possibilities.
Yeah, and we've also seen it where it's been designed where there's almost an impression, similar to how you use cores, where you have the impression in there, so hey, that's where your window is going to be for secondary machining. You can
Absolutely
fix that.
Absolutely. Oh, here we go. Draft.
Yes, there we go. Yes, you can never have too much draft, especially when it comes to gravity-fed castings. I would say, for the most part, depending upon the depth of the part, for example, shorter walls, you're going to need more draft. The longer the pool, the less draft you're going to need. And then you're always going to want to make sure your draft is moving away from your parting line. I don't know if there's anything else you want to add on that.
Yeah. Again, draft is important. If you think about what Rachel was talking about, we're casting in permanent mold, we're casting into steel molds. So you're removing a metal from a metal. So the best way to do that is Rachel stated, the more you get, the better. What's listed on the right side of the screen there are really kind of minimum draft requirements. But again, there's always the option afterwards to machine away in critical areas that are needed for less draft if that's a requirement.
Yeah.
Next, we'll talk about it on cord holes. So you can cast or you can design it on the mold, specific cord out holes or cord out sections of the part. So draft requirements there are a little bit different.
Yeah, but it's not too, it's a similar concept, but it's great for when you want to start machining the process afterwards, where to kind of start and get things going.
Absolutely. A little bit further on, we talk a little bit about what we call a semi-permanent mold casting, where You can cast in a sand core and have it shaken out, or you can have a different type of metal insert.
Yeah. So a lot of times you'll see those cores where you have sand cores in there is when you have an internal cavity, not necessarily almost a U-shaped.
Yeah, absolutely.
Part. Yeah.
Yeah, and it's used a lot in a lot of different applications. I'd say the primary use that we see for cored out products is somebody's running some kind of electrical or some kind of lines through it. Some other feature to really get that end application solved. It's a great process. It still gets the tolerancing on the permanent mold side of things that you would get from the steel mold, but has that hollowed out cavity inside that allows you to do those other applications.
Yep. Parting line. So I think this one is for the normal casting process. You're always going to have a cope and drag on a permanent mold, and actually majority of casting processes that use molds or steel molds. So it's important kind of just to make sure that you're evenly distributing the metal and that but for the most part, your foundry will be able to help you pinpoint where the best parting line would be for the part so you get the best cast end product.
It's important to try to work it out where it's not in a critical area.
Yep.
You know, if you got a design feature that you really need in your end product, we don't want to design that parting line because typically it gets blended in a polishing op. Sometimes it doesn't, but you definitely want it in an area where it's not on a critical feature there.
Yeah, and again, there's always secondaries to remove the additional draft that's added to help the part eject from the mold.
And I would say if with a good caster, they'll help you walk through where you should do it. Really interact with you, the end client, and understand your needs. But from a casting expert side of things, really help you understand, what's needed to make sure, again, we're getting the end goal in mind of a great casting with great quality coming out of the product here. Yep. So let's talk a little bit about concentricity. You see this a lot too. I mean, there's a lot of different concentric parts, a lot of circular hubs, a lot of different parts out there. You see it here, a good example on the bottom left there. So a lot of the dimensions, again, on the right here to keep in mind as you're designing it. You want to talk a little bit about it?
Sure. It's obviously you guys can read that, but the larger you get, the more the intolerance is going to increase across the parting line. But a good rule of thumb is adding 0.003 for every additional inch as your part grows to help make sure that you have a concentric part but have the tolerance to cast it. Linear tolerances. So just as a good rule of thumb or reminder is that these are as cast specs, so adding secondary machining can achieve tighter tolerances. So while these might seem pretty large compared to extruded or machined from billet parts, you can always go machine back down so that you can get to a closer tolerance to what you're looking for at the end of the product.
For comparison or for reference, your tolerance here starts, your linear tolerance here starts at 30 thousandths, but for sand casting 30 thousandths, but for permanent mold it starts at 15. So it just shows you a little bit of difference in what you're getting in each of those processes there.
Yeah.
And again, just in tolerancing in general, if it's not critical, don't over design it. Don't add, dimensionals that you need to hold in areas that really don't have any impact on the end part or the end application. Yeah. So again, with all this, designing it to the process, but designing it so that it works for your end goal and not overcomplicating it, adding costs in areas that you really don't need.
Yeah. Flatness. So you're never going to get a 100% flat part in casting. It's just the nature of the manufacturing process, just because you're going to have heat, torque, and the larger the part gets, the more tolerance you're going to need for your flatness spec. There are different ways that you can achieve a flat part through the process. There are fixturing you can use after you cast the part to kind of let the part sit and set in place, or you can even use heat treating to straighten. Although sometimes heat treat can do the exact opposite of what you want and cause it to even torque or what you call like a potato chip shape.
Yeah, it does add strength of the part. You're baking it, but it could add that potato chip effect, or it could bend the part based on the heat treat, based on the quench following it.
Yeah.
So again, when you're designing, something to keep in mind that we don't really go into too much detail in here about, but something to think about as you're designing it.
Yeah.
And oftentimes it allows us to add that extra step of flatness and straightening the part as well. So.
Yeah. Machine stock tolerance. So in general, rule of thumb, I would say permanent mold falls in the middle, where sand casting, you're going to need a little bit more stock on there to allow for machining, whereas you're going to get a little more tighter tolerance on permanent mold when it comes to near net shape castings. But yeah, you can again see the dimensions on the side, but you will need some extra material on your casting to be able to remove it a little bit so they can get to all the features you need.
Yeah, and I think that goes in turn with everything we've talked about prior to this, and some of the information we share after. But that's you get the near net shape. We talked about the windows and the holes. If you have that set up correctly and you're coring that out, it makes this a lot less important. You're not machining a ton off. You're just going in. You're doing a little bit of cleanup. But the tolerancing does give you an idea of what expectations you should have set in mind for end goals there.
Yeah. Logos, symbols, and letters. You're going to apply essentially a lot of the same thought processes we used in the beginning to this. So draft, make sure you have enough draft on these logos, letters, and symbols to make sure that the impression sticks. You have anything else to add to that?
Yeah, I mean, this is another great process for adding logos. Any kind of logos, verbiage, words, numbers, whatever it ends up being. The best thing about the permanent mold is we could create these as inserts. So even as the mold wears, still holding tolerance, still holding tight tolerance. If the logo wears a little bit faster, we can go in and we can remove the insert and replace it. It's a cheap cost to do so. So surface finish, I think this is one of the first things we talked about as a benefit to permanent mold. You want to go into a little bit of detail on this here, Rachel?
Yeah, when you're casting into permanent mold, you're casting into the steel, so you can get a much better surface finish, for example, compared to sand casting, which again, you're going to have more of the sand texture on the surface. So you can get anywhere from 200 up to 400 RMS on a permanent mold.
Yeah, no, I think the nice thing too is this gives you a range. Again, end goal in mind, as Rachel mentioned earlier, but if you are designing a part that's hidden, do you need 60? If you are designing a part that goes on a medical application, is 200 enough? And that's where I think the benefit of reaching out to your supplier or preferred supplier and really understanding capabilities, because what we do at our end is try to get the best surface finish coming out of the casting itself, which can actually be better than 200. We have a number of products that are 120 to 200 range, but we have processes here that allow us to get that coated application to stick, get that surface finish to be the end expectation. Robotic polishing in general, shot blasting, so a bunch of different opportunities to get it into that range as well. And goal in mind though, where do you need to be? What surface finish are you requiring, and what does your customer see? Do they see this in front of their face at their height, or is it something hidden and doesn't need that? With all that obviously comes cost. So.
And I think though one of the best things about permanent mold too is that, as Tim, our old VP of marketing would say, is the best surface you'll find in a permanent mold is below the surface because of how dense and low porosity the casting will be. So you can buff and machine and you'll still get a nice, good surface finish. Whereas maybe if you're looking at a high pressure casting, if you start going below the surface, you're going to get a lot more porosity and bubbles in there. So
sure,
you're going to get a nice finish no matter what.
Absolutely. So again, we'll bring this slide up again. Talked a lot about this early on. Rachel talked about the benefits of the permanent mold casting. So really, and on the last slide on surface finish, talked about it's great for dense castings.
Yep.
Using that gravity fed process, we can get into those complex areas. It's great on the food equipment. It's great on a lot of medical equipment because you can't get particles of anything trapped in this types of processes. It's great out of the mold for surface finish because of those same things. And then, high precision, high tolerance coming out. There's a lot of different additional benefits outside of that, but those are some things, a little bit different from what you may see in a die casting or a sand casting.
Yep. And again, this is all related to permanent mold, so to keep that in mind when you're looking at these design guides.
Appreciate the time.
Thanks, guys.
Thanks.
Thanks for listening to Casting Class, the engineer's podcast for all things metal casting. For more episodes, videos, and guides, check out BatesvilleProducts.com. See you next month.